Okay, everyone, let's start the session. Okay, so everyone, welcome to the third session of Android Compose Camp, which is in collaboration with the 5 colleges of Pune. So the camp leaders here will be me, which is Faizan, and with me is Nishant from Khandhar School of Engineering. We are both the facilitators of our respective colleges, and we'll be taking today's session. So without further wait, let's get started. For the Compose Camp session, Unit 3. The prerequisites for today's session is basic computer literacy. You should have completed Unit 1 of Android Basics with Compose, Unit 2 of Android Basics with Compose. You should have computer and headphones and an internet connection. Okay, so for today's Compose camp, a learning objectives will be to understand and learn Kotlin as an object-oriented programming language, build UI with Compose lazy lists, learn how to change the application icon, learn material designs with Compose, see the code working in Android Studio, discover the resources to continue learning. So this is today's schedule. Um, the Kotlin fundamentals will be the first one taken by Nishant, and I will be taking your Compose Jetpack sessions with scrollable view and app icon, and I will be teaching you material design as well. So this is the unit 3, wherein we have 3 pathways. The first one is the Kotlin fundamentals, which will be taught to you by Nishant, as I said. So he'll be taking over right now. Nishant, please take over.
Yes. Good evening, everyone. So let's start with today's session with Unit Third. That is more about Kotlin fundamentals. So in this session, we will learn about generics, object and extension, use Kotlin, collections Kotlin, arrays, lists, sets, and some practice questions uh, based on the topics we will learn today. Next slide. So yeah, everyone knows about classes. You maybe learn about classes in the previous sessions. So what is class? So in class, we so in classes, you use there are many different data types. So for every data type, different data types, you'll write separate program, which will be very lengthy. So basically, by using generic classes, you can reduce the length of your code. So by using the normal class, this will be the program you'll write. Uh, can you go to the previous slide? So yeah, let's take an example. We are writing an app code for app online quiz. In that, there are multiple types of quiz questions, that is filling the blanks or true or false, and some mathematical questions. So data type for each question will be different, right? Like for the filling the blanks question, the data type will be the string. For true or false questions, the data type will be boolean, and for the math problem, the data type will be the simple integer. So for each questions, we will write different classes, which is a very lengthy procedure, right? So using generic class, we can reduce this length of code and make it efficient. Next slide. When you want a property to have different data types, subclassing is not the answer. Instead, Kotlin provides something called generic type that allows you to have a single property that can have different data types depending on the specific use cases. So when you require any data type using generic class, you can reduce the length of the code. Next slide. So now let's see what is generic data type. Generic types, or generic for short, allows a data type such as class to specify an unknown placeholder data type that can be used with its properties and methods. What exactly does this mean? In the above example, instead of defining an answer property for each possible data type, you can create a single class to represent any question and use a placeholder name for the data type of the answer property. The actual data type string, int, boolean, etc. is specified when that class is instantiated. Whenever the placeholder name is used, the data type passed into the class is used instead. Now let's see the syntax, how to use this generic data type. This is the syntax of generic class. So it starts with the class keyword, then the name of the class, followed by angle bracket with generic data type, and the parenthesis. A generic data type is provided when instantiating a class, so it needs to be defined as part of the class signature. After the class name comes a left-facing angle bracket, followed by a placeholder name for the data type. The placeholder name can be anything, followed by a right-facing angle bracket. The placeholder name can then be used whenever you use a real data type within the class, such as for a property. So this will be the code after using the generic data type. Next slide. Next slide. To see how it works with multiple question types, filling the blanks, true or false, etc., we create without using the generic data type. We have created separate three separate instances for the question class. So by using the generic data type, you can see that the length of the code is reduced and the same pattern is followed. Next slide. So what is object? Object-oriented programming. Objects are basically the runtime entities of the class. So you can define many objects, but we'll talk about a singleton object. There are many scenarios when you want a class to have only one instance. For example, uh, interacting with a single hardware device like sending audio through a speaker. That means at a time you have to perform just only one task. In the above scenarios, you would probably need to use a class. However, you will only ever need to instantiate one instance of that class. So can you imagine if you connect a single speaker with two mobile devices and play at a time? So what happens? It create a chaos, right? So for that reason, the same case happens in the programming language. So to avoid those scenarios, we use a singleton object. Kotlin provides a special construct called an object that can be used to make a singleton class. Next slide. The syntax for an object is similar to that of a class. Simply simply use the object keyword instead of the class keyword. Access a singleton object. We access its property by referring to the name of the object itself, followed by the dot operator, followed by the property name. This is the syntax to access the data using object. Next slide. So let's talk about collections in Kotlin. In many apps, you have probably seen data described as a list, content, contacts, settings, search results, etc. Collection types, sometimes called as data structures. You may be familiar with the data structures like arrays, lists, etc. Let you store multiple values, typically of the same data type, in an organized way. A collection might be an ordered list, a grouping of unique values, or a mapping of values of one data type to values of another. The ability to effectively use collections enables you to implement common features of Android apps, such as scrolling lists, as well as solve a variety of real-life programming problems that involve arbitrary amounts of data. Next slide. So array. What is array? An array is a collection of homogeneous data. What does it mean? In other arrays, there are lots of data which is not similar. Like you can store string also and integer type also. But array stores the homogeneous data. You can store either only integer type of data or string type of data. It represents more than one value. An array contains multiple values called elements or sometimes items. Arrays are the and ordered data type and can be accessed with an index. The syntax to declare the array is given. The array of functions takes the array elements as parameter and returns an array of type matching the parameters passed in. Next slide. So after declaring the array, you need to access them for performing some various functions. So how to access the elements of an array? So as you know that the array is based on the index, every element of the array are given a separate index which starts from 0. The first element of the array is given the index 0. So to access the element, the syntax is array name followed by square bracket, and inside the square bracket, the index of the element need to be accessed. This is called subscript syntax. It consists of three parts: the name of the array, an opening and closing square bracket, the index of the array element in the square bracket. Next. This is the another collection in Kotlin, which is also known as list and data type list. A list is an order resizable collection. The drawback of array was that it can't be resized after once it is initialized. That is, if the size of the array is declared as 5, so when if you try to insert the element sixth element, then it will give you the error. So that drawback is covered by the list. List is an order resizable collection, typically implemented as a resizable array. When the array is filled to capacity and you try to insert a new element, the array is copied to a new bigger array. List is an interface that defines properties and methods related to a read-only ordered collection of items. Mutable list extends the list interface by defining methods to modify a list, such as adding and removing elements. Next slide. To perform various functions on list or operations on list, there are various functions, that is the list of functions. Like array of, the list of function takes the items as parameters but returns a list rather than array. So similarly, how to access the way we access the elements of the array, we can access the element from a list. Like an array, you can access an element at a specific index from a list using a subscript syntax. You can do the same using the get method. The subscript syntax and the get method take an int as a parameter, int data type as a parameter, and return the element at that index. So the syntax how to access the elements of the list is given. That is the print function using followed by the name variable name, list name dot get function followed by the index of the element of the list that needs to be accessed. Next slide. Next slide. No, that add element to list. So now let's see talk about the add function. How to add elements to a list, existing list. The ability to add, remove, and update elements in a collection is exclusively to classes that implement the mutable list interface. So this is the program in which the list is declared. That is val keyword followed by the name of the list and equals to list of function, and the parameters are taken, which are the elements of the list. So to add the element, the add function is used. Dot add followed by double quotes and the element which needs to be added. There are two types of add functions. The simple add, which will be added at the end of the list, and if you want to add the element at a particular index, then the another version of add which has the two parameters. The first parameter corresponds to an index at which the new element should be inserted, and the second parameter is the actual element that needs to be added to the list. So this is how you add the element in the two way into the list. Next slide. This is the another data structure or the collections of the Kotlin, which is set. It is also similar to array it doesn't have a specific order, but it doesn't allow the duplication of the value. In the array, you can add the duplicate values like multiple similar values like two twos, 5 times 3, or 2 times 5. The duplicate values are allowed in the array, but it in the case of sets, the duplicate values are not allowed. Like list, similar to list and arrays, it also has the function of add, remove, and content. The functions of the function add and remove are same as that of the array and list. The change is the content function. Content function takes a single specified content function takes a single parameter and checks if the specified element is contained in the set. Basically, it gives the answer in the form of Boolean data type, whether whether the entered element is present in the set or not. So the syntax for that is println the name of the set dot content followed by the parenthesis and the element to be checked whether it is present in the set or not. If the if the given element is present in the set, then the output will be true, or else it will give false. So basically, here the with along with the set data structure, the data type used is Boolean. Next slide. Uh, so the here's a task for you all. You need to implement the event class. This class is used to hold the details of the event entered by the user. Make sure the title in the event is a string, which uses a string data type. The description, which also use a string data type. Event data type as a string, and the duration, which is in minutes, should use the data type integer. This is the task or a homework for you to write the program using classes and the collections and data types. Next slide. And this is a task to create a list and perform the following operations on it. Uh, First of all, create any list, then try to add element randomly at the end of the list, and then try to add the element at a particular index, and try to remove the element from the list and print the following list. So yeah, that's all from my side. So then now you can continue. Over to you.
Okay, so we'll be starting with Jetpack Compose. So exactly what we'll do in Jetpack Compose is first we'll implement a scrollable list, an application, and then we'll add an icon to an application, and then we'll see how we design and format our application using material design, which is like a library that is offered to us by Google. Uh, this is pathway 2. Inside pathway 2, we'll be looking at lazy columns as scrollable list, importing compose classes in different Kotlin files, changing the application icon, how to use Image Asset Studio in Android Studio to generate launcher icon assets. What this means is that we'll be using Image Assist Studio in Android Studio to just make your application icons. What an adaptive icon is and why it's 2 layers. This is what you'll learn in pathway 2 of unit 3. So we'll be looking at what is a lazy column. A lazy column is a vertically scrolling list that only composes and lays out the currently visible items. As you can see here, it is like a list, but it contains collection of items inside the list, inside each element itself. As you can see, the first element is an extensible markup language called Kalkoti. Implementation of the scene in Compose. Before we start coding and start implementing this scrollable list using the lazy columns, Let's take a look at the components necessary for the scrollable lists. So what we require to implement the lazy column in Android Studio are the main activity.kotlin file, a data source.kotlin file in the data package. So you'll need to create a data package, and inside the data package, you'll need to create a file, a Kotlin file known called data source. And the third thing will be the affirmation Kotlin file, which will be a data class file in the module name package. The name of that package will be module, and inside which you will make an affirmation Kotlin file, which will be of data class type. So another thing that you need to know, this is like basically the environment that we are building in order to implement, because we need to implement a set of photos in a list which can be displayed to the user along with the strings below it. So we'll need to feed them to the feed them to the application before we code. So we'll have to store photos in resource drawable file, and there will be we'll also have to store strings in string resources, the names of the photos that we have decided. The description of the photos will be stored in a linear order in the string resource file, which is an extensible markup file from which we'll be picking them up and adding it to the lists. Okay, so these are the five components that you need to set in as an environment to start coding lazy column in our application. So these are the functions used in main activity. As we saw before in the previous slide, that main activity.kotlin file was was where we will be coding. It's like the main activity which will display to the user a lazy column. So inside this main activity, we'll have five functions. The first one will be the onCreate function. If you must have taken the previous lectures, you must have understood that onCreate function is like the basic starting point of your program, the starting point of your activity in, Android application. It's like the main function in Java, wherein the execution starts from the main function itself. So this will be one of the functions. The second function that we will write will be affirmation app. This app will contain the calling of the function affirmation list, which will contain the calling of the function affirmation card. And affirmation card preview, which is the last function, would be simply to show a preview at the side. The preview is something you see on your code, like your user interface, how it will look on an Android application. So these are the five functions that we will code in main activity, and the classes used in this project. This is an entire project in which we'll be creating multiple files, as I said before. And in this project, there are three classes. First is the affirmation data class. The second one is the data source class, and the third one is the main activity class. Okay, so these are the three classes that we will be using for this project. Okay, so first, as I said, we'll be setting up the environment. We'll be setting up all the resources we need to implement lazy column in our uh, application. So first, we need to go inside the drawable folder, the drawable directory, and all the images that are supposed to be displayed in the list in the lazy column are added in the drawable directory in the resource directory. As you can see here on the right, there are images numbered from 1 to 10. These are the images that we will be displaying on the user on the UI. So we are placing these images in the drawable folder inside the resource folder. This is something you have to do before you start programming, because you'll be extracting these resources using Kotlin and Compose. So as you can see on the right, there is a values folder inside the drawable folder as well. So here inside the values folder, you will find a string resource extensible markup file. Inside this file, you need to place all the string names, all this. You can see, as you can see here, inside the compiler photo, there are names displayed in order as well, numbering from 1 to 10. These are all the text that will be displayed below the images in your list. So this should be placed inside the string resource. If you've attended previous lectures, or if you're familiar with Android Studio, you must know that these string resources are used frequently by programmers to replace the hard-coded texts in case they need to change that, and they are accessed by the name which is mentioned in front. As you can see here, the happy name is affirmation, which is this represents the application name that you will see on your home page. If I change this name to any name, you will be seeing that name instead for your application on your home page. So this will be it for the string resource. So now we'll be looking into onCreate function. The onCreate function, as I said, is the function from where the execution of the program starts. In this case, the execution of your Android application, the first activity will start from onCreate function. This will be from inside the main activity file. So inside the onCreate function, we'll be setting content. The set content, if you've attended the previous lecture, you might know that set content is for setting the content of the user interface. So it basically calls onto the compose library for implementing the user interface using states. So this is the lazy call theme. This is simply the name of the package that I have made, the lazy call. And the theme is something that we need to implement in order to call onto the functions without the compilation error. So inside this, as you've seen, we've called on to the affirmation application function. So this is all we are doing in this. So inside our main function, which is here an onCreate function, inside the main activity, we are calling on to an application, to a function called affirmation application. So this function I have declared in the same file itself, and we'll see what it does. So this is the affirmation app function. Inside affirmation app function, I've called onto the affirmation list function. And as you can see, there is a composable annotation at the top left corner of this, which denotes that this affirmation app function belongs to the compose library. So it is a composable function. This affirmation list function that it calls on to has a parameter, as you can see. The parameter name is affirmation list. Now, this list, affirmation list, is a name of a list, the name that I have given to the list. And as you can see here, there is data source and there is load affirmation, which I have initialized it with, or rather assigned it to. So this data source is exactly a function which is used to extract data from another function. The data source is a class, and load affirmation is a function. My bad. The load affirmation is a function which is used to extract data values from the data source class. As you've seen before in the previous slide, the data source was another file that we've created, and it was the name of a class as well. So inside that class will be our data. There will be our images and our string resources called on inside that file, inside the directory which was named data. So with this function added to it, we are calling on to affirmation list, the list that we've declared to store all our values. Okay, so we'll be moving forward. So this is the affirmation list function, the one that we called in the previous slide. Uh, I'm elaborating that function right now. So inside the affirmation list function, as you've seen, we've declared a parameter. The parameter name is affirmation list, which is of the type affirmation. It is a list of the type affirmation. And what affirmation is? Affirmation is a class in another file that we've seen. I'll be explaining you this. So I'll be starting on the Android Studio as well in a bit, in a while, after I've explained this to you correctly, so that you can have a hands-on, or uh, rather live demo of how it's implemented, actually, how I have implemented this using using these code lines. So as I've said before, this formation list is a parameter which calls on to all the data present in the list, which includes images and text. And the second parameter is modifier. Modifier is basically to format our images and uh, make them seem more better. And as you've seen here, the lazy column. The lazy column is actually a composable what should we say? It's like a composable component which is used to contain elements. Yeah, it's a container. It's used to contain elements like a column and rows. If you attended previous lectures, you must have understood what a row is, what a column is, and the lazy column is just like those. But unlike column, a lazy column is a little different. It resonates more with a recycle view. The column is used to display elements in a vertical order, and it does not have a scrollable. However, for lazy column, you get a scrollable list, and the second thing you get is that those elements that you load on to the user interface gets loaded from the backend. So it's the data that you can extract from the database. Unlike in the column, that data that you have passed to the column is already on the front end. So it's not something that you can change later on. So the data inside the lazy column can be changed. That's exactly why we implement the lazy column. So inside lazy column, as you can see, we've declared a function items. The items function is used to call on to the list and display its items serially. So inside lazy column, we see the items function and which gives call to the affirmation card function. So the affirmation card function is being given a call, and affirmation here is an object. The affirmation at the top, where in the inside the parameter list type, you can see that affirmation has an A with a capital A. So that is the data type. That is the data type given to the list, and that data type is a class. So the affirmation with the capital A is a class name, and the affirmation with a small a, as you can see below here, I've written it as an object of the same class. So this is an object that I've declared of an affirmation of the affirmation class, and we've passed this object of the affirmation class, which contains the list values, to the affirmation card function. So now we'll be seeing what the affirmation card function does. It is like the most important function that we'll be using to implement the lazy column. So moving on to the affirmation card function. So as you can see, affirmation card function is a composable function as well. So inside this composable function, you can see the affirmation object declared. So the affirmation object that we were using in our affirmation list function, it has been declared here as a parameter. And the modify parameter is also here. This is like an instance of the modifier, component. So we are using the card inside this function. Now, what is card? If you have done recycle, you must be knowing. But for those that are new, the card is basically to make an element out of you. As you've seen, we are using two components. One is the image, as the another one is the string, and we are both displaying them as a single object, uh, and we are we are making a list out of those objects basically. So what this card is doing is that it is making like a user interface component, one element of the list that is supposed to be displayed, and that element contains these two sub elements, which are the image and the text. And this is a container as well. As you can see, inside card we've declared column. So the so the images and the string will be declared in the vertical will be present in the vertical manner inside one card. So it is making a format for one element of the list. As you can see here, the image is placed first and the text is placed second. So inside the photo, as I have told before, the as I've shown you before, rather, the image was placed first and the text was placed second. That is exactly what this is doing. The image is placed here first because it is mentioned first inside a card, and they are placed in a vertical order. That is because of this column container. We are using these modifier functions inside to fill max width and height of a certain length, as well as we are using the content scale to make a content as much as a Android phone screen is, so that it can adjust itself according to the difference in the screen, so that a part of its content does not get cut out for different phones. Um, so this is the same for both the style tag, or the style attribute of the modifier content component inside the text. inside the text, you can see the style is used for material theme. The material theme part will come a little later. The typography is H6. As if you've done HTML, you must have known the header tags, which range from H1 to H6. This is something similar. Yeah, using the H6 format, um, which will display the text in H6 size. So this is the affirmation card preview function. So this is a preview function, and if you have attended the previous lectures, you must know what this preview function is. And this simply shows the affirmation card function. So you will be seeing the affirmation card, the first element inside your preview. Okay. So this is the affirmation.kt file, the affirmation Kotlin file, the affirmation inside which I've declared the affirmation class. So this is what I've been calling on. Inside this, you can see there are two resources. One is a drawable resources and one is a string resource. The drawable resource contains the image. The images that we have stored in the drawable folder before, they are being called on here. And the strings that we have stored in a string resource file in the extensible markup language file are being called on here inside the data class affirmation, which are then being called as a single element inside the data source class, which we'll be seeing now. See, as you've seen, this contains a list of about 10 elements, which is a combination of strings and drawable. And this is returning. This is a function called load affirmations. We've declared that function here, defined that function here, and we have a list over here as well. In other words, this is a return type. It returns a list, and here this is a return type, which is the list as well. And inside this list, we are declaring all these elements to be a part of that list. So if you can uh, join together all that we've learned, you must be understanding how we are implementing this. So I'll be showing you a live demonstration as well in case you are finding this bored or other uninteresting, so that you can understand exactly how we've done it. I'll be opening the Android Studio as well. As you can see, we'll see it in action. So just wait a minute until I open the Android Studio. The Android Studio is a resource intensive IDE, so it will take a minute or two for it to load all the files. Okay, so as you've seen, the Android Studio has been loaded. Inside this Android Studio, we are inside main activity. The main activity contains all those 5 functions that I've told. This is the onCreate function I was talking about that we've seen. Inside this, we are calling the affirmation app function. The affirmation app function is declared over here, which is being called over in the above function in the onCreate function. And inside affirmation app, we are calling affirmation list function. The affirmation list function is over here. Inside affirmation list function, we are declaring lazy column, which calls on to the items of affirmation card. Affirmation card function is basically for a single item. The item that you see, just let me show you the preview. The preview is loading over here, so it will take a minute about. Yeah, as you can see the preview here, it shows only one element of your list. That is because in the preview function, I have given the only the affirmation card. The affirmation card, as I said, declares only one element. It rather formats your element of one element of your list, which contains multiple such elements. So this is one element. So this is what affirmation card is doing. So now we'll be inside the main function, as I've said, we have called on not to the affirmation card, but to the affirmation app function here. This function, with the help of affirmation list function, makes a lazy column out of all these elements. So it displays all these elements over here. Let me show you the affirmation file as well. And this is the data source file, when all your string elements are placed. And let me show you how it runs on an AVD, Android Virtual Device, which is a virtual machine of Android device. Okay, so you must be seeing here below the Gradle build is running. It takes a minute for this Android device to start up and set up our application and install our application in this virtual Android device. So it will take a minute. So please be patient. Okay, it's installing. The application is installing now. Okay, fine. The AVD has started. See, as you can see, this is the application. This is what we are trying to build through lazy column. This is basically a collection of these affirmation card functions that are being displayed in an order, which is because of this affirmation list function you can see in the left, which is then being called on to the on create function, which is like the starting activity. So the moment I open my application, I'm looking at this list, and this is a scrollable list, which is composed of 10 images and 10 text files, which are placed sequentially below each other. Yes, so this is what we are trying to implement, and this is what we have done using lazy column. So just to summarize, what we have done over here is there are five functions. The first one is affirmation app, affirmation list, affirmation card. These are basically the three important functions that we are using to implement it. The other two functions is one is on create which is like a main method where we are calling on to the affirmation app function, and the last one is for a preview wherein I've given affirmation card function. So only one element, so only first element was being displayed in a preview as you've seen. However, unlike in a preview, here we can see the entire list because I have passed this function which contains the entire list here loaded through lazy column. Okay, so that's about it for the demonstration. I will be starting with the next topic now. I'm closing this. Okay, so let's see how to change the app icon. So right now we've seen we had that blue logo on our application. Instead of that, if we want to keep something else for our Android application, um, how can we do that? First, we'll see what an application icon is. I've informally explained you what it is. So an application icon is an important way to differentiate your application by adding a distinct style and appearance. The app icon appears in a number of places, including the home screen. I mean, the home screen is where it belongs actually. The app, the all apps screen and the settings app is also where you can find these application icons. They are also called as launcher icons. Here you can see the Chrome has an application icon. The default application icon is that Android bot face that you've seen in most general. I'll show you that as well. And here we'll see how to change an application icon. You can see here there are multiple application icons. One is for Drive, one is for Chrome, one is for Crop, and all of them are formatted and made in a certain way. Okay, the adding an application icon is not that hard. However, there is a reason why they're teaching us to add application icon and why it is a topic in the code labs that you'll be doing. So before we start, or before we know how we can change the application icon, application icon for our application. So it has some important screen. So one is the screen density. How many pixels from dots per inch from the internet and your books. So that is 160 inch. So for 1 inch, there is 160 dots or 160 pixels on the screen for an average phone. However, for some phones with ultra high definition or 4K or 8K views or something, for now the 4K is the max, I believe, for Android. Here it requires an XXX HDPI, which is extra high density device, which has 640 dots per inch. In other words, it has 640 pixels per inch on the screen. So what I'm trying to say is that if for different devices there is different DPI, then for those devices our application icon will be displayed with different, you could say, sizes, because as you've seen in normal cases, the photos are usually called on with their sizing is basically done in terms of pixels and not inches. So if a 420 pixel images, 420 by 420 pixel images were to be displayed on the MDPI device with medium density display device, so on it will cover 4 inches or 3.5 inches, somewhere around 3 to 4 inches. But on an X triple X HDPI device with 4K quality, which has 640 pixels per inch, it will display half of an inch. So the size of an image differs. That's exactly why we need to understand how we should set our application icon. So it doesn't vary and differ from application to application or from uh, device to device. This is the first term that we are looking at. The second term is density qualifiers. What is a density qualifier? The density qualifiers contain the vector, the drawable folders first. They contain the vector for the launcher icon in XML file. A vector in the case of drawable icon is a series of instructions. Sorry, it is a series of instructions that draw an image when it is compiled. So we use a vector for our icons. We don't use a raster, because a raster, I will be explaining you that a little later. I mean, in just next 1 or 2 slides, you'll be understanding why we are not using a raster. So for a different densities, screen densities, we'll be using a vector so that it does not get blur as we zoom in. Uh, so the density qualifiers are those that you can append onto the name of a resource file directory, like a min map. So minmap, you'll be seeing what it is exactly in the further slides as well, to indicate that these resources for the device of a certain screen density. Okay? So these are for a certain screen density. So they have basically declared different density qualifier for different screen densities. So they have basically 6 or 7 different types of vector images placed inside these directories of density qualifiers for different types of screens. So for different types of screens, they will display different application icons. So that's what they're trying to tell you here. Here, this is what I was talking about, the density qualifiers. This is a list of density qualifiers. You have about 6 to 7 density qualifiers. 1, 2, 3, 4, 5, 6, and 7. Yes, you have 7 density qualifiers. Um, of varying density, screen density. As you can see, this is 160, which is medium. This is 240, which is high density. This is 320, which is extra high density. 480, 640. And NODPI are not meant to be scaled. This is for those that have constant uh, images, more like for your raster images, in case you have those for your application icons. On the left, you can see this is how you will see it on your Android Studio. On the right, my bad. On the right, you'll see these in the min map NEDPI V26, which stands for version 26. This contains an XML file. So I've talked about vectors that you'll be using for your application icon. So these vectors are present in an XML format, an extensible markup language format. So this extensible markup language defines how your vector looks. You can place a raster or a normal PNG file as well, but it won't be scaled and it might get blurry from phone to phone. So that is something we must avoid as Android developers. So these are all the min maps that I've shown you, the density qualifiers. So now you see this, the adaptive icons. What are adaptive icons? So the adaptive icons consist of two layers. You can see the GIF over here. It contains of the background and the foreground. The foreground and the foreground overlaps the background and displays your icon in a circular way, as you can see. The rest, uh, it keeps it translucent. Sometimes it keeps it transparent. Sometimes, or it covers it with an entirely different color of its own. You can specify it yourself, and we will be seeing how we do that later. As you can see here, it works for above Android 8.8. So if you have an operating system of less than Android 8, this adaptive icons will not work. So these adaptive icons gives more flexibility and interesting visual effects. As I said before, it has a foreground layer and a background layer. So we'll be seeing the difference between a drawable and a bitmap image. This is not inside your code lab, or maybe it is, but not in such depth. They haven't stressed this much. But I felt the need to stress this because it is something you must understand very importantly while you are doing the Android application, when you are formatting the application icon importantly. Okay, so the bitmap image is what we'll be looking at first. Um, the bitmap image doesn't understand how much image that it holds, how much information about image that it holds, except for the color information only. That is at each pixel. So for each pixel, it has a color information. So the more you scale, the uh, the blurry it gets because it's like being stretched. On the other hand, a vector graphics knows how to draw shapes that define an image. So it will redraw the shapes as you keep on zooming into the image. So it will be clear. It will not be blurred because it will keep on redrawing those images uh, in accordance to your zoom. So it's not. So that's like an added advantage for vectors uh, in comparison with bitmap. These instructions are composed of a set of points, lines, curves along with the color information. So unlike bitmap, which is more pixelated and the information is stored pixel by pixel, here it is stored in the forms of points, lines, and curves, which are changeable so that it can redraw itself whenever needed. A vector drawable. So this is what we are using for an Android's application icon, which is a vector drawable that is in the form of XML file, as I've said before. You've even seen the photo of that on the right hand side. You'll be seeing it in ahead as well. A vector drawable is Android's implementation of vector graphics, intended to be flexible on mobile device. You can define them in extensible markup language with these possible elements. Instead of providing a wide range of bitmap assets for all density buckets, you only need to define the image once, thus reducing the size of your application and making it easier to maintain. So unlike a raster image or a bitmap image, it does not get blurry. So as we were doing before, we were defining six different density specifiers, you could say, for different screen density types, right? We had six types of screen density types, and for all in all those we are storing a bitmap image. So instead of doing that, we can just declare a vector drawable application icon, and that will be enough. It will adjust itself according to the screen on its own. So we won't be needing to use all six types of different images with different image screen densities for different phones. So this greatly reduces the problem and makes it easier for us as well. As this is like a visual representation of what I've told you. The vector, despite zooming, retains its quality, retains its Um, it does not get blurry, it's still clear. However, the bitmap, because of being pixelated, gets blurry. And you can see the pixels as well. The advantage is written below. If it is scaled, it still shows you without losing any quality. So the first thing, now we are starting with how with the steps required for changing the application icon. The step one we see is to download new assets. Okay, so we will be downloading an extensible markup language. Now I can't make my own extensible markup language icon right. No, I can't. So I can make as well. It's not that hard. However, for this, for our compose course, they have provided us some on their code lab, which we'll have to download and which we'll be downloading in an Android Studio, and we will be placing it there. I'll show you where. So now we are deleting our already existing uh, resources. And as you can see here, we have to delete the old drawable resources that contain Android icon and green grid background in the project view. The right click on the right click on the file and choose delete. So what they are doing is inside a drawable folder. I've shown you what we are doing with drawable folder. Inside a drawable folder, we have multiple files. Oh, we've placed our images that we were going to extract in a lazy view as well there. And here and inside the drawable folder itself, we have our icon extensible markup languages in a vector format, in XML form. So we are deleting the already existing one because we want to replace them with the one that we have downloaded because we want a better application with a better application icon over there. So we are downloading the one they have provided us with, and we delete the min map images as well, which are of the bitmap form. So here, after we do that, we have to create a new image asset. We will be seeing, and if you click on the project side above, you have to go onto the drawable resources and then right click and then add your new icon images, icon extensible markup language. So we are using both of these. So for adaptive icons, we have the file image. So as shown here by the red, you can click on the plus button and you can add those downloaded resources that you got from the core labs. As you can see on the right side, background will be different on it. Okay, background is here. This is for adaptive icons. So we are using both of these. So all that we are learning, we are applying it right away. These are the images I've used for to implement lazy view, as I've told you. So these images also placed beside that. However, we are using these two only for our icon application icon because these two are of extensible markup language type, which are of vector format. So these are the details that we need to fill in. The first thing is for foreground layer. How you want your foreground layer to be? Should it be circle? Should it be a square and circle mixed like with the rounded borders? Should it be a rounded square? Should it be a square, a complete square, a full bled layer with sharp sides, and many more options are available over there. And we choose image for foreground as you've seen here. We keep the name IC launcher because we'll be using this in our Android manifest file, which is also of XML type, which is there for both compose and extensible markup language in case you use that for a UI. So we press next, and this is the foreground where I've told you we are we are using the source asset of asset type image, and we are placing the path of that image of our drawable file where we've placed it over here. We are copying it and placing it over here. That's exactly what the step 5 shows, which we are doing for foreground layer, and we are doing the same for the background. And we choose the asset type to be image, and we name it as well. We copy the path and place it from the drawable resource, and here we can see this is the image that we have downloaded. So we can already see here that it is being formatted and it's previewing us how our application icon will be looking. Okay, so we are still on this tab as well. Instead of these androids over here that we are looking at this green background, we are looking at this now after we have presented them with the path to our new XML files which contain the vectors. So here you can see we can also scale them in case we need to increase the size of our foreground or background. So we need to format a bit more if in case you need formatting, that is. And then you just press a finish over here, and that will be it. You can see that affirmation tab on your home page. You need to test your app. You need to go to the home page and then check if your application is doing the same. Okay, so we are done with the pathway 2. There is a practice grid application as well that I expect you to do. You can find the same in the code lab in the pathway 2. So we'll be looking at pathway 3 now. So inside pathway 3, we'll be learning material design. So what is a material design? Material design is a design system created by Google to build high quality digital experiences for Android. So now we are using Compose UI to format our background and to add user interface elements that can interact with the users. But to customize those elements, we need something more than Compose. We need another library, another system that the Google created to assist Compose. Material design can also be used by by XML files. They have a separate part. The material design beta is for uh, Compose, and we'll be using that. And you'll see how we'll be using that. The lazy view list that we've implemented, we will be formatting that as well. So we'll also be understanding what is material theming, because the material design allows you to theme your applications, which I said, which is like basically customizing your applications. So you'll be using material theming to do the same. So here you'll learn in this pathway how to apply material theming, how to add custom fonts to your application, how to add custom color palette to your application, custom shapes to your application, and and here you can see the does work in Android Studio, how we are using Android Studio, and in what way we are calling onto the colors. We can't just put their name. There are very few colors that have been declared in colors XML file or another resource, Kotlin file, which contains the names of the colors that we'll be using. But here we usually use the header of the colors. If you must be using HTML or CSS, you must be familiar with the standard type, which we are also using in an Android Studio. The first one is red, the second one is green, the third one is blue. The alpha here is used to denote whether the opacity of the color that you're using, like from 0 to 100%, how much transparent or opaque you want your image, your color to be. So that is declared by these first two letters of the hex value, and the hash character is the like denote the starting of it all. So this is the application that we'll start with. So since here we are only learning how to customize our application, right? So for this, we are already being provided with a lazy list by our, by what do we say, by our code labs. So they have given you this application before, and they expect you to customize this color this and format this to make it look more better, to make it look more interactive and attractive. Yeah, attractive and intuitive. So this is the application that you're looking it look more attractive. Colors that we'll be using, these are the names of the colors that we'll be specifying. So this is the hex value that we will be specifying. So this is the hex value. This hex value is used to denote the, like the color that we will be using. So this is the hex value. This hex value is used to denote the color that we will be using. So this is the hex value. This hex value is used to denote the color that we will be using. So is how we call on these colors inside our if you're giving what these slots are, you must be knowing what the background can predict as well. The rest I'll be showing you in the following slides. This is the color assignment, the primary color, the secondary color, the background, and the on color. The primary color is the color displayed most frequently across the application screen. The second most used color is secondary color, which you use along with your primary color to make it more distinctive, make its appearance more appealing. The surface color is also a color with which is more like for our cards. Like I said, I have told you before, we've been implementing card view as an element. So for one element, for one row, you'll be having that color, which is the surface color, and background color I've told you before. The on color elements are not that important for now. So this dark theme also we can add. What we'll be starting with, I'll be explaining you the light theme, and the dark theme can be added in the same way. We'll be coming for the dark theme as well. But first, I'll show you how we implement the light theme. So for light theme, we are using in color.kt file. Color.kt file is your Kotlin file, which you will see in uh, in your Java main file inside your applications file. In this file, you go and you declare these variables, these five variables, and name these variables and assign them to their colors. So the next time you need to call on to these colors in your main function, you don't need these hex values. You need these variable names. This is what we are doing. We are adding a color palette to our theme. So here, this is a theme.kt file. If you were paying attention to our program, we are using something called lazy call theme. So this theme is something that Android Studio adds for every project that we create for compose, and in the theme.kt file we can assign these colors, the variable names as well. uh, this variable is light color palette, and inside this we are declaring the names, and we are specifying basically the slots for which we are assigning these colors to. But just assigning them these slots doesn't give them. We need to format them with the help of the modifier inside the main program. We'll be seeing how we do that now. Okay, first, before we do that, there's this Woof theme that they have implemented for this specific app. So for our app, that was a lazy column app, lazy column theme, right? For this, their project name must be Woof. So the Android application, so the Android Studio will give them the Woof theme using the like theme.kt file. You can see which contains all of this. So this will be, and we'll along with the slide color palette in our main program. So we are now adding the colors to the application. It's time to use them in a main application so that we can see the effects of it. This is how we have added the background color. We go on to the lazy column modifier, and we are now adding in the main activity function a background modifier. We need to add a background modifier on the lazy column. We are using modifier as a parameter. So modifier is a parameter, and inside a modifier we have a modifier. We have declared a modifier instance, option we are using from materials for the green you are looking at on your right, and then we'll be giving the giving color to the surface. As I've said before, the surface is your rose. So you'll be giving them a rather light color because this is a light theme, and this is how you do it. Inside the card, in a few slides later, because only a part of the formatting can be done with the rows. We can't edit the shapes. So for shapes, we will be using the card view again, which we've done before, so that we can implement it better way. So here inside the row modifier, you can see there is dot fill max width. This is to fill the entire width. However, there is 8 padding, so you can see this space here. This is because we declared the 8 padding, or it would have filled up the entire space over here. And the background is for background attribute, which is for the background of this and this row only. So this background here denotes the color that we give to this row. The material theme dot colors dot surface here gives you the surface color, the name that you've given to the surface color over here before. If I show you the previous slides, this is the surface color green 50, and the green 50 we've declared to the hash color this one, and this was this color, which is the other white color. That is exactly why our rows are looking rather white. And this is the dark themes. If you use the different color palette, the dark theme color palette, as you can see here, instead of the light theme, and you do the same you do the same thing that you've repeated over here. You repeat the same things, my bad, that you've done here, and you'll get this instead. So now we've learned how we make the colors. We format it. We color our background and we customize it. We customize the colors in our application. Now we'll be seeing how we can shape our rows. If we want to make it more appealing to our users, we need to do something more, right? To make them to make it look more of this era, this 21st century application. So we are starting with the shape in Android. For this, we need to open the shape.kt file, which is used to define shapes and so these files that I'm mentioning, the shape.kt file, the color.kt file, theme.kt file, these three Kotlin files are present inside the Java file of the directory as well. I'll show you where these are present in a while. I'll open the Android Studio again and then show you so that you can have a better understanding of what I'm teaching you. So these are the three components of this the shapes. The shapes library that we have imported in the shapes.kt file, the small, medium, and large. In this section, you will modify the card component, which is defined as the medium size. So our card component will be of a medium size. So before this, as I said, we were using rows and we were formatting rows and coloring them. But now, because the rows shape cannot be changed, we are using card components. So for instead of rows, there will be cards over there. We'll be defining a card and we'll be formatting the card now, not the row, so that we can mix its shape and shape it as we please. So before we shape our rows, we need to shape these images inside the rows of the dogs that we've seen. We'll do that first by opening the main activity. And inside the main activity, we'll declare a function dog icon, and inside this function we add a clip attribute to the modifier of the image. So this function is something that basically exists already, because this is a function that contains the images of the dogs in a rows. So they've already provided us inside this application before we format it. So we are using this, and we are using the modifier attribute like we have done before, and we will use the rounded corner shape method, like dot rounded corner shape method for modifier. We've seen how we are doing this here. Like for background, we are using dot background and then material color, material theme colors. The same way we are using dot rounded corner shape over there to make corner, and inside this we can pass the amount of roundedness. I mean, the amount of the how much round you want your rows to be, or your card element to be. So here we've passed 50 to make it a little round. So this is the dog image in a circle. we need to shape the dog image in a circle, and that's what we have done here. We've made them a little round. As you can see, they are rounded, not as pointed as before. They were of square shape before, and now we have made them of round shape. As you've seen here before, we are using a clip function, and inside this we are using a rounded corner shape function, and inside that we are giving a parameter value of 50. So this accepts a value. This is an inbuilt function, uh, and this dot clip function is also an inbuilt function of the modifier component. Okay, so we've done this for the images. As you've seen, the image container is what we are modifying inside the dog function. So that's what we have done to make these images rounded. And this is what we had to do. So this slide had to come before this slide actually, because after we've done, no, this has to come after this, because now that we have shaped our files, our photos of dogs, we are now trying to make our borders rounded. As you've seen, the borders of our rows here are pointed and of a rectangle shape, and we need to make it rather more rounded. But here, after you've applied the rounded corner shape uh, function for all these cards, or you could say rows, you see that it has occupied all of it, and it's not even looking like a list anymore. Rather, it's not even looking like a lazy list anymore, and the formatting we've done kind of looks useless here. So in order for us not to do this, we will be applying padding over in between these two rows, so that we can shape it. We can see we can present it as a list with a more formatted user interface. So here you've seen that we've achieved that. How we are doing it? We are using padding for rows, and we are using padding for card as well. So here we have used a little bit padding, and we have used padding between rows as well, so that you can see that they are evenly spaced now, and they are not colliding. They are not merging with each other that like they were doing before. The padding that we have given to them is of 8 dp 8 pixel. So that's about it. So that's it. The next session that you'll have is would be on Sunday, and that will be on Unit 4. The prerequisites for the next session will be for to complete your compose basic course from Unit 1 to Unit 3, and install Android Studio as well. So that will be it for today. Thank you. Uh, so we'll be ending the session soon now. Thank you.